So this is the conclusions chapter from Alexander Thom's Megalithic Lunar Observatories. It has been shown elsewhere that there existed in Britain in megalithic times a widespread knowledge of geometry. We find designs drawn with the same conventions set out on the ground and inscribed on rocks and stones. In both there is the same insistence on integral lengths. The linear unit that we find on the rock designs is 0.816 inch, or exactly 1/40th of the megalithic yard used in ground plans. The designer undoubtedly used a set of beam compasses with the distance between the inscribing points advancing by units or half units. This explains the preoccupation with integral lengths and the necessity of using triangles with sides of integral length satisfying the Pythagorean theorem. With this background, we need not be surprised to find an intense interest in astronomy. Time of night was found by the stars rising, transiting or setting. Time of year came from a highly developed calendar, linked accurately to the sun in such a manner that the necessity for inserting the intercalary day every 4th year would have become apparent in a few years. I have shown elsewhere, Thom 1967, that the calendar itself was capable of giving the exact day of the solstice, and yet we find accurate solstitial observatories. In chapter 10 of this book, Megalithic Observatories, it is suggested that these were used to predict the date of the coming standstill. But this use did not need the accuracy that we find at, for example, Kintraw. At Kintraw, a 5° Fahrenheit change in temperature would affect the sun's apparent declination by about 0.5, and so would have been obvious. Here then at Kintraw is an instrument capable of showing clearly that on a particularly cold mid-winter evening the sun appeared slightly raised. It was only natural that a people looking critically at the setting sun would use the same observing method on the moon. But here they found a much more complicated motion. They would see that it was only at the standstills that anything like repeatable results could be obtained. But the rapidity with which the moon passes through the monthly declination maximum set them a serious problem, namely that of extrapolation. Did they solve this problem by first making it geometrical? If they tried the effect of stepping back each night as shown in figure 1.1, they would have been able to apply their knowledge of the geometry of the flat arc. We know how much time they must have spent at the problem at numerous observatories throughout the country, and it would be strange indeed if they had not somewhere tried out this method of avoiding confusion as the stake position moved first one way and then the other. This method would show the constancy of what we have called the Sagata, G, and would have led to the method of finding G at any site with sufficient clear ground. They were now ready to tackle the problem of the quadratic relation between the stake interval and the extrapolation distance. The evidence suggests strongly that they solved the problem in an entirely satisfactory manner, perhaps even more satisfactory than the inevitable anomalies in the apparent motion allowed them to realise. They could now place the stake for the monthly declination maximum. If we have formed a correct idea of their method of thought, then the next step was obvious. They would have applied the same type of reasoning to the monthly maxima as they had used in handling the nightly stake positions at the declination maxima. This gave them, as we have seen, two methods of finding in retrospect the exact date of the perturbation maximum. They were also in a position to demonstrate the constancy of the 173.3 day period and to apply it successively to predict the dates of the maxima until the next opportunity of observing, i.e. at the next standstill. While the existence of the lunar observatories is beyond dispute, there seems to be no definite evidence that the main object was eclipse prediction. And if it were, why are there so many observatories? Possible answers are 1. Poor communications, 2. Lack of uniformity in the calendars used in different districts. 3. Replacement of obsolete observatories by more up-to-date ones. Of the 3, the last seems to be the most likely. To settle this point conclusively, we need some independent method of dating by archaeological methods. The cooperation of archaeologists is also needed to find out if any of the sites were re-erected. Assuming that the cult lasted for several centuries, the obligatory changes would make it desirable to move the back sites. Can this be proved or disproved by excavation, or are present excavation techniques or interpretations of excavations still too crude? Large menhirs go deep into the ground, and some trace of a change in position should surely be left. In some places we want to know if there are traces of menhirs now removed, and in others, e.g. mid-cliff, we want to know the original position of fallen menhirs. The intense interest taken in the moon's movements must have led the more acute minds to seek a deeper understanding. These people were certainly not inferior to us in ability to think. How much did scientific curiosity affect the work at the observatories, and how much could the observatories have contributed to knowledge? The fluctuating nature of the lengths of the synodic and tropical months must have been puzzling, and the constancy of the 173.3-day period would have been some relief. If they had noticed at the celestial sites the effect of the progressive fall in the value of the obligatory, they would be prepared for a similar effect on the moon. But on a short run of observations, this is obscured by the peculiar effect of parallax described in chapter 7.5. A long series of observations extending over several centuries could have shown the periodic nature of this apparent parallax fluctuation. It has a double amplitude of about 7 foot. If they had not detected this, it must have been by chance that the lunar observatories were erected from observations extending through exactly the right period of time to show so nearly the same value of E as we find at the celestial observatories. The erectors evidently attached great importance to lunar sites. This is apparent from the complexity of the sites in Caithness and the large menhirs and alignments used elsewhere. The list of known sites includes nearly a dozen alignments, and among these are to be found some of the most impressive alignments in Britain, e.g. Callanish, Ballamenok, Escott and Parky Mere. An outstanding feature is the height of many of the menhirs, e.g. Knockstaple 11 foot, Parky Moor 11 foot, Campbell Town 11 foot, Camas and Stacker 12 foot, Balmartin 12 foot, London Links 14 foot, Callanish 14 foot and Beerchar 15 feet. Other sites may contain more massive stones, but the lunar sites often have the tallest menhirs. The alignments indicated the foresight and, when there is now only a single menhir, if it was a slab, the flat faces were orientated on the foresight. Judging by these districts that have been closely examined, it is probably safe to say that at least one lunar site was to be found in each part of the country where there are other megalithic remains. On the west coast of Scotland we find them in Lewis, North East, Mull, Tipperary, Jurey, Giga, Kintyre and other parts of Argyllshire. We cannot speak about Skye because the church caused nearly all the stones in the island to be thrown down, just as in earlier years papal authority was given for the destruction of Avebury. As is to be expected, we find the same general distribution of calendar sites. In this connection it should be remembered that one calendar line in a district is sufficient to keep the calendar linked to the sun. There are celestial sites in many places, but only in South Argyllshire do we find a group with 4 sites of sufficient accuracy to permit of the kind of analysis attempted in Chapter 4. South Argyllshire is also peculiarly rich in lunar sites. In the district covered by the map in Figure 11.1, there are over a dozen known sites, and the examination of Islay and Arran is incomplete. The reason for this large number is not clear, but one may wonder if some of these stones belonging to the earlier days of the cult, when it was considered that the backside ought to be set up for a limit or limits of the perturbation rather than for its node. It will be noticed that apart from the fully developed observatories, there is only one stone, Campbell Town, for the node. Are we seeing in the duplication of observatories an attempt to minimise the effects of cloudy or misty weather, or did poor communications make it desirable for each district to be independent? Neither explanation seems entirely satisfactory. Anyone who makes a detailed study of the more advanced sites like Temple Wood and Ballymenoch will realise that the people who built them possessed a highly developed knowledge of the complicated movements of the moon in the sky, and that they must have employed some form of extrapolation. The implications are far-reaching. The design of the necessary sectors, whether obtained by pure reason or by some complex empirical operation, demanded a highly trained intellect. The discipline necessary could not have arisen out of nothing. There must have been behind it a school or a system of mathematical reasoning, also evidenced by the remarkable designs that we find in the complex rings described in Thom 1967 and in the so-called cup and ring marks. A study of the latter will be found in Thom 1968-1969. They seem to show a concentration on trial and error, which may have been applied successfully to the extrapolation problem. Nevertheless, the trials, to be ultimately successful, must have been guided by rather more than a mathematical intuition. How far advanced they really were is not yet clear. It is to be hoped that this monograph does not give the impression that a study of these remains from the astronomical point of view is complete. It is only begun, but it must be pursued quickly before the sites suffer further damage. In this century, to the author's knowledge, aerodromes, roads, reservoirs, housing, quarries, agriculture and forestry have all taken their toll, and the pace of destruction is quickening. One well-meaning individual took a stone into his garden to preserve it. Another man here was cut up by a mason to make lintels. Farmers have removed large outliers, and so it goes on. The author makes a plea for the position of every stone near a site, however insignificant looking, to be recorded exactly before the information it may hold is lost forever. Even at this late day, something may be saved. Archaeologists and archaeological societies are aware of the danger, as is also the Forestry Commission, but we need the cooperation of the man in the street. The archaeological remains in which this country is so rich are our heritage and our responsibility. We must do our best to preserve them for posterity.